All right, we're back. We're on page 8 of notes 24 of Calc AB. This is solving differential equations. You also need this in Calc BC if you happen to be watching the video, so don't think you're getting out of it. So let's see if we can do this. So the differential equation dy dx equals x squared times y cubed. X squared y cubed, I think is how I wanted to say that, has a particular solution y equals f of x that passes through the point 3, -1. All right, all good. A, write the equation for the line tangent to the graph of y equals f of x at x equals 3. All right, we can do that. So we're going to need the slope, right? So that's not a pen. So dy dx at 3, -1 is going to be, so our differential equation is this. So if x is 3, then, and y is -1, I think we just get 9 times -1, so -9. So our tangent line is going to be, so point slope form, so y plus 1, -9, x minus 3. Okay, use the tangent line to approximate f of 2.9. So it's an approximation, so use approximately equal to. So f of 2.9, it's approximately -1 minus 9 times 2.9 minus 3, which is so -1 minus 9 times -0.1. -1 plus 0.9, so negative 0.1. I think that's right. Negative 0.1 times 9 is 0.9. Yeah, okay, I'm pretty confident in that. Next up, find the second derivative in terms of x and y. Super common, right? So it's always going to say in terms of x and y because you're not allowed to leave a dy dx in there. Also, don't forget, you're going to need dy dx's with the chain rule. So let's see if we can do this. So the second derivative. So remember, we're going back to the differential equation. So it's a product, so we're going to use product rule. First derivative of the second is 3y squared dy dx plus second, which is y cubed, derivative of the first, which is 2x. Okay, but we're not allowed to leave that dy dx. So this will be 3x squared y squared times x squared y cubed, oh boy, plus y cubed, 2y cubed, plus 2y cubed, 2xy cubed, I think is what I want to say here, 2xy cubed, 2xy cubed. All right, that feels right, I guess. I don't really know. Okay, so that, I guess if we work it out, that's going to be 3x to the 4th, y to the 5th, plus 2xy cubed. And like you could factor that, but I don't know. If I need to, I'll do it, but like I think I'm okay with as it is. Find the particular solution. Okay. So so we're gonna probably separate and integrate. So dy dx is x squared y cubed. So I gotta start with that. Dy dx is x squared y cubed. Okay, so then that means dy. So all right, I'm going to divide both sides by y cubed. So I get dy over y cubed. I would prefer to write that as y to the -3rd dy because I'm more comfortable integrating y to the -3rd than I am 1 over y cubed. That's the only reason I'm doing that. And then on this side, you just get x squared dx. Integral, integral. And then that's a weak integral sign. Let me try again. I'm not good. So I teach a lot of calculus. I'm not good at drawing integral signs, and I'm terrible at drawing summations. And like so much of my day is taken up with drawing those. And it's like, is it a lack of effort or a lack of ability? Yes, probably both of those. All right, plus 1 times reciprocal. 1/2 y to the -2nd is equal to 1/3 x cubed plus c. I'm going to solve for c right now because it's not going to look better as I keep going. So I'm going to use the initial condition and solve for c. So if I plug in, I get -1 squared is just 1. And then this is 27 divided by 3 is 9 plus c. So c is going to be, negative 19 halves. Kind of gross. All right, so we're definitely not done because we don't have y equals f of x. We have, like, I don't know, y to the negative second right now. So let's continue. So I'm going to take this, and I'm going to take this, and say that negative 1/2 y to the negative second is 1/3 x cubed minus 19 halves. All right, I like to take these a step at a time because there's a lot of places you can make a mistake. So what I'm going to do is multiply through by -2 and get y to the negative second. You know what I'm going to do, though? I'm going to make it 1 over y squared here because I don't want to make a dumb mistake, basically. And I think I will if I leave it as y to the negative second. So I multiply through by -2 here. That gives me, I'm going to write it as 19 minus 2/3 x cubed. Okay, now I need to get y squared, so I'm going to take the reciprocal of everything. So it's y squared is 1 over, can I make this bigger for everybody? Not that much. 19 minus 2/3 x cubed. All right. So what issues am I seeing here? There's like a potential domain issue, which could be bad. But I think it's not a part of the differential equation, right? The differential equation itself doesn't have any problems with x being any value. It's our particular solution that might have that. So I'm not sure how much I'm going to worry about that. I do see a problem here where I'm about to take a square root. So let's do that. So y is equal to plus or minus the square root of this. So I'm going to write 1 over the square root of 19 minus, I'm a little afraid of what answer the calculator will give me when I like ask it, because like this is a weird answer. I think it's going to like maybe rationalize something. I don't know. We'll find out maybe. All right, so f of 3 is -1. So here's the sticky part, right? Here we have y is less than 0, right? Because y is -1. So we have to choose the negative square root. So therefore, let's like write that a little more officially. Let's say since f of 3 is -1, we know that y is less than 0. Therefore, our solution is actually -1 over square root of 19 minus 2/3 x cubed. Woo! So that's our solution, I guess. I'm gonna highlight this. Generally speaking, not really a highlighter guy, but technology-wise, turns out always a highlighter guy. What's left here? All right, there's only one thing that we have to do. Okay, so that's good. Based on your answer to part C, so this is actually an interesting question. Based on your answer to part C, is it reasonable to have approximated f of 2.9 in part A? If so, is it an over or underestimate? So is it reasonable? So what that's basically saying is we used x equals 3 for our tangent line, and then we approximated f of 2.9. The question is, like, are those in the domain of our solution? Because if they're not, then like we really should not have done that. So what on earth is the domain of this thing? I would need 19 minus 2/3 x cubed to be greater than 0. So 19 minus 2/3 x cubed greater than 0. That's our domain, right? So negative 19, what are we doing? Negative, well, when in doubt, just do the actual work, right? Negative 19, multiply by 3, divide by -2, we're gonna flip the sign. So 3 is 57 over 2. And the cube root of 57 over 2, I don't know. 57 over 2 is like 28.5-ish. So like bigger than 3, right? So as long as x is less than some number that is bigger than 3, which is a weird way of saying that. So I need x to be less than 57 over 2 to the 1/3. So yeah, so therefore, yes, valid. Barely though, right? So we're in the domain. Like our approximation value is in the domain. Where we wrote the tangent line is in the domain, so it works. These are the sorts of weird things that like you don't think about sometimes when you're doing these, but you really should. All right, so it would have been better for us maybe if it wasn't in the domain, because now we have to explain if it's an over or under estimate. So I'm going to go up here. I'm going to look at our second derivative and see if we can work out if the second derivative is positive or negative, and then make a conclusion based on that. So my second derivative, okay, so I'm going to set this up. So I know that 2.9 is less than x is less than 3. Actually, we can do equal to. It doesn't really make a difference. Therefore, x is greater than 0 really is what I needed. Therefore, x is greater than 0. All right, that's definitely true. Also, I know that y is definitely less than 0. So I guess I should say and y is less than 0. I know y is less than 0 because for my solution, I had to choose the positive square root or the negative square root. I chose the negative. It can only spit out negatives. So y is definitely negative. All right, what does that mean? So therefore, it's like a double therefore. The second derivative is, so x is positive, which means, so I'm looking up here. I should probably copy it down, but I'm just going to look up here. X is positive, so this is positive because it's to the fourth. That's positive for sure. And then y is less than 0, which means that overall this product is negative, and overall this product is negative, which means that overall the second derivative is less than 0. So overall second derivative is less than 0. So less than 0 means concave down. The function, the solution is concave down. Concave down means the tangent line is above, which means we got an overestimate. So there. So I'm going to say since y equals f of x is concave down, tangent line gives an overestimate. Whew. This is a good problem. A lot going on in it. How much do you think our calculator can help us with this? I'm not really sure because it's not super great at finding the second derivative, or perhaps I don't really know how to make it do that. I think what I can do though, all right, so if this messes up the video, I'm just gonna cut the video and we'll all pretend that it didn't happen. I'm gonna try DE solve. No, I'm not gonna try that. Oh yeah, I am gonna try that. DE solve y prime equals x squared y cubed. And should we do and? And y of 3 is -1 comma x comma y. Oh man, let's try to solve that for y. Okay, so it gave me either the positive or the negative. Can I like stipulate? Let's do such that y is less than 0 and see if, no, you really can't. Like it won't do that. Okay, but like the one that we wanted, holy cow, there's a lot going on there. This is the one that we wanted. So is this equivalent to what we got? We got -1 over the square root of 19 minus 2/3 x cubed. I feel like it is. Negative, oh my gosh, what are you doing? Yes, those are equivalent. So you can work it out. You pull everything under the same radical, and then why can you take a negative out? Oh, it's got a negative inside. That's weird. -3 over this. Bring this negative to the denominator. You have +3 on the top. 57 minus 2x cubed. 57 minus 2x cubed. A +3. Bring them all under the same radical. They're equivalent. Okay, so we got that. What could I do with this? I could find the second derivative. So this is how you like fake your way to this answer. Okay. How am I gonna tell if this? So this is I want to know when the answer here is less than 0. What are we going to get back? Let's do decimals. Delete that. Decimals. Yeah, if we're between 0 and 3 point whatever, concave down. So worked out. All right. So I'm gonna call that a win. You have to do the logical thing though that we did. Like you can't really rely on the technology for this. It's just like we wanted to check it. So hopefully this is coming back in the video right now. And you can see this argument that we made where x is between 2.9 and 3, so greater than 0, y is less than 0. That was required. Like the technology thing, super helpful, but like, you know, not something that we could have really done by hand. Well, actually you could have, but like you don't want it. Anyway, I'm gonna end this video here, come back in the next video, finish this page, maybe keep going, probably not. I like to keep the pages separate when I make these, but I'll be back, so I will see you then.